Hello everyone, this is Dr. Giuliano. We're going to be talking about how to interpret the results of a correlation coefficient in a journal article. So what is correlation? Correlation is the association between two continuous variables. This relationship is explained by the correlation coefficient, also known as R, or the Pearson's correlation coefficient, which is one type of correlation coefficient. These values range from -1 to 1 and are unitless. The closer you are to 1 or -1, the stronger the relationship is. Now, positive relationships, as one variable increases, the other increases. Let's look at an example. We would expect that grades and hours studied for an exam are associated. So as the number of hours goes up, grades go up, and vice versa. We don't know which one is kind of leading the other. They're just associated with each other. And that would be a positive correlation. Now, negative correlations are inversely related. So if we looked at the number of beers and the grade, we might expect that as beers increase, grades go down, or maybe because grades go down, beers increase, but we don't necessarily know which one led to the other. They're just associated with each other, but this is an example of a negative correlation. What is the null hypothesis for correlation? It's that there is no correlation, or that the correlation coefficient R is 0. Now, you have to be very careful, especially with large data sets, because it's easy to reject the null hypothesis, but capture not clinically significant associations. One example is a correlation of 0.02 with a p-value of less than 0.05. While the correlation is statistically significant, the R clinical significance value is going to be debated, and of course it always depends on what you're measuring to determine clinical significance. Now let's go over the assumptions of the correlation coefficient for the Pearson's correlation coefficient. The first assumption is going to be that the data must be from a representative sample from one population. That means it just has to represent the population you're studying. The second being that the observations must be independent. You're only looking at one subject, you're not counting them multiple times, they shouldn't be closely related. The third assumption is that X is not used to compute Y, because then they would automatically be correlated to some degree. And then X is not experimentally controlled, like a continuous variable like drug dosage. You can't have as your X value. Both X and Y must follow an approximate normal distribution. Now, if this is violated, there is another type of correlation coefficient that we'll talk about here in a second. And then it also has to be linear relationship. Now, if either normal distribution or linear are violated, we can use the Spearman rank correlation coefficient. And what this does is it ranks the values and then it correlates the ranks of the values together. Now, if the linear assumption is violated and we use Spearman rank, the relationship still needs to be monotonic, which means that the values are always increasing or decreasing. Now let's talk about a value called the R-squared. The R-squared is the correlation coefficient squared. It explains the variance in one factor by another, or the variance of the association. If the R squared is 0.4, that means 40% of the variance is explained by the relationship between the two variables, while 60% of the variance is unaccounted for and is explained by other factors or some type of error that's occurring. When evaluating correlation, it's important to remember that correlation evaluates association, and correlation is not causation. Why? Well, there's a few problems with correlation. One, it's not always clear which factor is affecting the other. Is it the number of beers that's affecting grades, or is it grades that are affecting the number of beers? There may be an unknown factor that influences both factors. For example, one study evaluating the number of cups of tea and the development of lung cancer found that tea drinkers had less lung cancer, but it was just because they smoked less, and it wasn't a real correlation between tea drinking and lung cancer. It could be part of a more complex interrelated relationship where there's lots of different factors affecting each other. And lastly, it could be a type 1 error. Now, it can be helpful to look at graphical representations of the correlation. These aren't always provided in journal articles, but I at least want to show you why it's useful to be able to examine the scatter plot of a correlation. So we're going to use a 0.8 correlation coefficient. We're going to draw a few different graphs. The first graph is going to be a little bit more scattered, but linear. The second graph is going to have a major outlier. The third graph is going to be a nonlinear curved relationship. And the last graph is actually, most of the values are constant, with one outlier that makes the relationship have a R of 0.8. Now let's draw lines through all of these here. And you're going to see we'll have very similar lines, but the data all mean something very different. So it's important to look at the graphical representation of the data, because the R's might be the same, but they might be telling you something different. Now let's talk about non-significant relationships. Just because a relationship is non-significant does not mean there's not a nonlinear relationship. So this is a nonlinear relationship that would have an R of 0. Here's another example of an R of 0, but there's a clear pattern going on with the data. Let's look at another example. This has a clear pattern to the data. The R will be 0 here. And then lastly, we have, again, a non-linear relationship where the R will be 0. So it's always important to look at the graphical representation of the data, because it may be telling you something, although a correlation coefficient is going to evaluate a linear association, and the relationship just may not be linear itself. The principles of correlation are used heavily in regressions, so it's important to watch this video prior to watching the regression video.